In this video, we're going to talk about the process of balancing chemical equations. There's two things that you need to understand about a chemical equation before we can get to this. Now we're going to stick with the red lightsaber to show the evilness of this topic of witchcraft. But the first thing I need to point out to you with a chemical equation, and this, by the way, is the chemical equation for photosynthesis. We've got carbon dioxide and water being used to make glucose, which is sugar, and oxygen. So this is the process that plants go through, but there are two parts of the equation I want to talk to you about. The first one are called coefficients. These are the numbers on the outside of our parentheses. What these numbers do is they tell us how many of each molecule you're going to have. So this is a molecule of water. We've got a 6 on the outside. So what we end up doing with this 6 is we distribute this, just like you would distribute a concept in math. For example, like if you had 2 distributed across x plus 2, that would end up giving you 2x plus 4. So you would just take that 2 and you distribute it across both of those factors. We're seeing the same thing here. You would take this 6 and you would multiply it by the 2 in hydrogen. So this tells us there's actually 12 hydrogens here. There's an implied 1 if there are not any numbers written. So in this case, 6H2O would give us 12 hydrogens. 6 times 2 gives us the 12, and then 6 times the implied 1 gives us 1 oxygen. The thing that you can change when it comes to chemical equations is you can change the coefficient, the number out in front. The thing you cannot change is this guy, the subscript. We are stuck with the subscripts. So you're stuck with having 12 hydrogens over there in that glucose molecule. There's nothing you can do to change that. All you can do is change the change the coefficient in front of it in order to change those numbers. So we'll go through 2 examples and I'll show you what to do when it comes to balancing some simple equations. So if we're looking at this first example, the very first thing you have to do is write down the different elements that are seen on both sides of the equation. So in this example, we've got magnesium and oxygen on both sides. The trick is you need to get the same number on both sides of the equation. So the very first thing to do is to go through and count up how many of each one we have. If we take a look at the magnesium over here, there is no coefficient in front of it, there's no subscript, so we only have one of those. Now there's 2 oxygens, the subscript tells us that, and we're just going to keep track with tallies, because that's going to make things a little bit easier as we go through this, since this number, the number that we're writing down here, is going to be changing as we go. Tallies are a lot easier than like erasing it and replacing it with something else. And then on the right, we've got 1 magnesium and 1 oxygen. So again, remember, if there is no subscript written and then no coefficient, we're assuming that it's a 1. It's a safe assumption to make. So what I would suggest people do is look where there's a discrepancy. We've got 2 oxygens on the left, only 1 oxygen on the right, which means this is not balanced at this point. So in order to balance this out, what we're going to do is add some parentheses and put a 2 in front as our coefficient in front of the magnesium and oxygen on the right-hand side. This is going to bump up our tallies for both of these from 1 to 2. So now our oxygens are totally balanced. We've got 2 oxygens on the left and 2 oxygens on the right, but if we come back up here to the top, now you can see our magnesiums are off. So what we're going to have to do to balance that one out is add a 2 in front of this one as well. Now we have 2 on both sides. One thing that I want to stress with you is in this particular example, this one works out where we have 2 magnesiums and 2 oxygens. These numbers don't all have to be the same. They just have to be the same across. You need the same number of magnesiums and the same number of oxygens. But if this one, just for example, happened to be 4 and the magnesium was still 2, that's okay. There's nothing wrong with that. Now we'll get rid of those just so that doesn't confuse anybody, because that would obviously not be the correct answer here. But these don't have to all be the same number. It just so happens for this particular example that they all end up being 2. We'll look at one that's a little bit more complex that doesn't involve all of the same answers for each element in the next example. So in this example, and this one I would like you to sort of write down and go along and do with me as I go through and answer this, but here we have nitrogen and hydrogen. So again, we'll write those on both sides. And you always want to write the same element across from itself. So like you've got your nitrogens here and then nitrogens across, hydrogens here and then hydrogens across. Because that's kind of how we're reading this. We're reading it across in both directions. So again, the first thing is to count up how many of each element we currently have. So there's 2 nitrogens. Again, the little subscript 2 tells us that one. And then we have 2 hydrogens. Now, on the other side, our numbers are vastly different. If we're looking at this over here, we only have 1 nitrogen, implied 1, and then 3 hydrogens. So in this case, all of the numbers are unbalanced. If you want to go through and try to balance one first, we'll say, hey, how about we balance the nitrogens, because they're pretty close. So we've got 2 on this side and only 1 on this side. We'll add the coefficient 2 in front of our product. That's going to bring us up to 2 over here, but it's actually going to total us all the way up to 6 with our hydrogen. The way to balance this one out, if we look back on the other side, we'll need to get our H2 equal to 6. So if we change our coefficient there to a 3, now we've got 3 times 2 gives us 6 total hydrogens. So we've now got the same number on both sides for each of these. Again, remember, you're reading them across. Nitrogens are even, the hydrogens are even. This is now a fully balanced equation. I think the easiest way to do this is if you follow these steps and just write out everything that I was asking for with the answers down here at the bottom, going through and making sure that you write down the elements on either side and then just comparing them up across the reaction. There's one more that I would like you to complete on your own and to put your answer in at the end of the video. The final equation for you, and this one's a little bit more complicated. We've got Cu, which is copper, and there's 2 of those with an oxygen. That's added together with a carbon, yielding copper by itself on the right, and carbon dioxide, CO2. So take a second, write that one out on a piece of paper, balance it, and then you'll submit your answer at the end of the video, telling me what the balanced equation is for that one. We'll be practicing some of these in class as well. Just remember the strategies that we talked about. You want to make sure that you write down all of the elements on each side first, and then go through and balance each one. So good luck with that. We'll talk about it more in class tomorrow.